In this video, we're going to have a look at what are like terms. Like terms are terms that meet the following criteria. To be a like term, they need to have the same variable or variables. The second criteria is that each variable needs to be raised to the same power. If the variables are not raised to the same power, then there cannot be like terms. So let's have a look at a couple of examples that will help us to identify what are like terms and what are not like terms. So have a look at some examples. In our first line, they are like terms because each term contains the letter m or the variable m. So each term contains the same variable. In the second line, they're like terms because each term contains the same group of variables, so a p and an a. Now, it doesn't matter what order the variables are in. As you can see, we've got a combination of AP and then we've got a PA. Variables can be in any order as long as they contain all of the same variables. So each of these terms contain an A and a P, so they're alike terms. So in our last line of examples, each term contains a T squared. Now, because each of them contains a T squared, they are like terms. If we had an example that only contained a T and not a T square, then it would not be a like term with T squared. They've got to have the same power. So let's have a look at some non-examples. What are not like terms? In our first line, we have terms that contain all different variables. So because they contain all different variables, we don't have any like terms. In the second row, I've got three terms. I've got an F, a G, and an FG. Now, because each of these terms contain different variables or different mixture of variables, and they're not all the same, we don't have any like terms. And in the last example, I've got a G to the power of 2, a G to the power of 5, a G and a G to the power of 3. Even though I have the same variable being G, they're all raised to different powers. Because they're all raised to different powers, they will not be like terms. So let's have a look at some examples where we have to identify the like terms. In A, I've got a 19A, a 7B, 8C, 8, and A. The two that will be like terms will be the 19A and the A, because they contain the same variable. Having a look at B, I've got an X, a Y, an XY, an XZ, and a YX. The two that are going to be like terms are the XY and the YX, because both of these terms contain both an X and a Y, and they can be in any order. So it doesn't matter that they're not in the same order, they will be considered like terms. In C, I've got a 3, a 3x, a 3xy, and a 4yx. The like terms are going to be 3xy and 4yx, because they can contain the same variables within the term. And the last example, D, I've got an 8m, an m, an 8, a 2m, and a 2b. My like terms are going to be all the terms that contain m. So I've got an 8m, an m, and a 2m.